Bismillahirrahmanirrahim. Welcome to VCI YouTube channel. Dear friends, we are going to explain the setting out a simple curve by perpendicular offsets from tangents. Perpendicular offsets from tangent method is used when the center of the curve is not visible due to some obstacle like crops, bushes, etc., or due to much distance away. It means that this method will be used when the center of the curve is not visible and the center of the curve is far up from the tangent point and the curve. Then we will use this method. In this method, perpendicular offset are drawn at equal interval of distance on the tangent lines. It shows that when we use this formula, then the tangent line will be divided into equal interval of distance. The value of these offsets are calculated by the following formula. The perpendicular offsets can be found by this formula, which is Ox is equal to r minus under root r square minus x square, where Ox is equal to perpendicular offsets at a distance of x from tangent lines, and r is equal to the radius of curve. X is equal to distance of peg interval from tangent points. As we have said that the perpendicular offset divided by this formula Ox is equal to r minus under root r square minus x square, but we are going to find the proof of perpendicular offset formula from the given figure. So this is a given figure which r is equal to the radius of curve. As you can see that this is a radius of this curve, so r is equal to the radius of curve. This is also the radius of curve, and x is equal to the distance. It is the distance which is it is the distance from a tangent point on the tangent line. As you can see here that this is a tangent point which we have shown here, this tangent point 1, and the distance from this tangent point on the tangent line, so this is denoted by x. Now by getting a triangle, we have to require to get a triangle. Let consider a radius which cross the long chord and touch the curve. So you can see here that the broken line is considered as a radius which start from this origin which cross the long chord and touch the curve. So this is the radius which is equal to this radius and this radius because of a simple curve. And the second point, draw a parallel projection of x length up to consider radius. Second point shows that x length, draw the x length projection up to radius which is equal to x. As you know that the broken line shows the projection of this length and the length of this projection is equal to exactly of this length. So, and the third we say that therefore we have a triangle RXOX. Now by Pythagorean theorem, Ox is equal to under root r square minus x square. So third point means that as we have a projection of this lines x which is exactly equal to this interval, and this is the considered radius. Now by Pythagorean theorem we will get this distance by under root r minus x r square minus x square, which is the Pythagorean theorem. So we have a distance this which is denoted by Ox which is equal to under root r square minus x square. So and now we know that the perpendicular offset A is equal to r minus Ox. It means that this is the perpendicular offset which is which have exactly 90 degree with this tangent line. It means that this perpendicular offset can be found from this r divided minus this distance which is Ox. It means that total radius minus this Ox. So you can see here that upset A is equal to r minus ox, which is equal to r, which is the exact radius of the curve, and minus ox, which is equal to under root r square minus x square. So this distance we get by Pythagorean theorem, and this is the previous radius of the curve. I hope that you will clear your concept, and you know about the proof of this formula, that how we can get this formula from this trigonometry. I hope that you will clear your concept. Most welcome for next videos. Thank you.